Hi there, good day. Having troubles in functions and relations? Well, you've come to the right place. Today I'm going to explain more on functions and relations. Key ideas. So, we have here function and relation. So, function is a relation where each element in the domain is related to only one value in the range by some rule. The elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output, while relation is a rule that relates values from a set of values called the domain to a second set of values called the range. The elements of the domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more outputs. Also, don't forget that all functions are relation, but not all relations are function. Here are five different ways of expressing functions and relations: set of ordered pairs, table of values, mappings, graph, and equation. So, the first way in expressing functions and relations is set of ordered pairs. Set of ordered pairs is composed of two coordinates. The x coordinate is the abscissa, and the y coordinate or the ordinate. As what I've said earlier, that in a set of ordered pairs, the domain is the set of all x coordinates, while the range is the set of all the y coordinates. The set of ordered pairs can be considered as a function if every element in the set is composed of different x and y coordinates, and no common x coordinates exist in a given set. So here are examples of set of ordered pairs. First example, 1 and 2, 2 and 3, 3 and 4, 4 and 5. It is a function because the domain is not repeated. Second example, 1 and 3, 0 and 3, 2 and 1, 4 and 2. It's a function because the domain is not repeated. But as you can see, the range is repeated. So you will ask, how about the range is repeated, then why is it not a function? It's because we do not include the range in looking if it's a function or relation. Third example, 1 and 6, 2 and 5, 1 and 9, 4 and 3. It's a relation because the domain is repeated. Fourth example, negative 3 and 7, negative 1 and 5, 0 and negative 2, 5 and 9, 5 and 3. It's a relation because the domain is repeated. And the last example, negative 2 and 0, negative 1 and negative 2, 0 and 3, 4 and negative 1, 5 and negative 3. It's a function because the domain is not repeated. So, here is the second way in expressing functions and relations is table of values. Table of values is a set of ordered pairs can be written as a table of values still composed of x and y coordinate. The x coordinates are written on the first row and below are the y coordinates. Always remember that we can transform a set of ordered pairs into table of values and vice versa. The number of columns depends on the number of ordered pairs given, plus 1, for the column of x and y. A table of values is a function if there are no common coordinates in the row of x coordinates. So here are examples of table of values. First example, 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10. So in here, we will just substitute the domain in the x. As you can see, there are no repeated domains, so it's a function. Second example, 1 and 4, 4 and 7, 3 and 10, 4 and 13. What do you think it is? Is it a function or relation? It's a relation. Because x is repeated, therefore it's a function. The examples 3 and 4 are other examples of table values. Just like the other examples. So, here is the third way in expressing function and relations is mappings. Mappings function that can be written as mappings in which the values on the left side, which represents the x coordinates, will be matched with the values on the right, which represent the y coordinates. So here are examples of mappings. First example, 0 and negative 2, 1 and 1, 2 and 2, 3 and 4. So here, we will just put the domain and range vertically and matched with the values on the right. So what do you think this is? A function or relation? Yes, it's a function because the domain did not repeat. Next, we have the second example. Negative 2 and 1, negative 2 and 3, 0 and negative 3, 1 and 4, 3 and 1. Just like the first example, we will just put the domain and the range vertically, then correct it to the other side. So, is this a function or a relation? Yes, it is a relation because the domain is repeating. As you can see, I only put 1 and negative 2. That means we don't have to put the repeated number again. But that is just mapping. So, here is the fourth way in expressing function and relations, and it is graph. Graph is a vertical line test that can be used in order to determine if a graph is a function or merely a relation. How are you going to use the vertical line test? First, draw a vertical line passing through the graph in the rectangular coordinate plane. Then, determine the number of points of intersection between the graph and the vertical line. Always remember that if there is only one point of intersection between the graph and the vertical line, then the graph is a graph of a function. But if there is more than one point of intersection, then the graph is just a relation. So here are examples of graphing. Just always remember that if there is only one point of intersection between the graph and the vertical line, then the graph is a graph of function. But if there is more than one point of intersection, then the graph is just a relation. So last and not the least, equations. Equation functions and relations can be expressed by means of an equation. And always remember that we cannot consider an equation a function if, first, there is no y in the equation. Second, the exponent of y is an even number. Third, y is in the absolute value symbol. And last, the relationship is not in the equality form. Here are the examples of equations. First example, y is equal to x to the power of 2 plus 2x plus 1. It is a function. Next example, y is less than 3x minus 2. It's a relation. You know why? Because y is not in equality form. Third example, y is equal to x to the power of 2 plus 2. It is a function. Next is x greater than y is a relation because it's not in equality form. Last example, y to the power of 2 is equal to x plus 2 is a relation because the exponent of y is even. So that is all for functions and relations. I hope you learned something from my discussion. This is John Reynardo Gumapak signing off. Keep safe, everyone.